Imagine a really busy construction site. It's almost like a symphony, isn't it? You hear the rhythmic clang of steel on steel, the focused roar of heavy machinery, the shouts of crew members calling out instructions, coordinating these really complex movements. You see cranes lifting massive beams just with incredible precision, workers skillfully putting together intricate parts, and well, slowly from the ground up, a structure starts to take shape, changing the skyline right before your eyes. It feels like controlled chaos, maybe, a real marvel of human ingenuity and just sheer collaboration. But what truly makes this incredible symphony possible? I mean, it's far more than just the cranes and the hard hats you actually see on the site. It's this invisible, incredibly intricate global network. It stretches from, I don't know, remote quarries on one continent to high-tech factories on another, all working diligently behind the scenes to bring every single nut, bolt, beam, and pane of glass to exactly where it needs to be, precisely when it needs to be there. It's quite something. Welcome to the deep dive. Today we're taking a deep dive into the incredibly complex and honestly often surprisingly fragile world of construction logistics. We're talking about the huge supply chain that underpins every single building project we see around us. We're going to pull back the curtain on this colossal, mostly unseen flow of materials, specialized equipment, and even highly skilled labor that all has to converge, often against some pretty immense odds to, well, bring our built environment to life. Our mission here today is really to give you a shortcut to being truly well informed about this really fundamental aspect of our modern world. We want to expose some surprising facts you might not have thought about, demystify the sheer complexity of this global network, and ultimately reveal a pretty profound truth. Any construction project, whether it's a small house in the suburbs or a towering, ambitious skyscraper, it's truly only as strong as its weakest link. And that link is often hidden deep within this supply chain. And to help us navigate this intricate landscape, we've gathered a really fascinating and diverse stack of sources today. We're drawing from comprehensive project management guides, like the PMBO guide. We've got cutting-edge BIM handbooks that give us a glimpse into the future of digital construction. We've even got historical architectural texts showing how monumental structures were built way back in ancient times, and some modern lean research that's all about optimizing efficiency. Each of these offers a unique and I think vital perspective on not just how things get built, but maybe more importantly, what can go wrong and how the industry is learning to adapt. Okay, so let's unpack this. Let's really pull back that curtain on this often overlooked but absolutely crucial aspect of building our world. So when we picture a construction site, it's rarely just an isolated patch of dirt, right, where a building just pops up. Our sources again and again frame it as a point of convergence, a convergence for this massive global flow of materials, equipment, and labor. Just think about that for a second. The structural steel, maybe it's fabricated in China. The timber, sourced from sustainable forests in, say, Canada. Highly specialized machinery, manufactured thousands of miles away in Germany. And the skilled labor, sometimes they come from across international borders too. All of it has to arrive at this one specific location, often at a very specific time, and be ready to go.
It's an enormous undertaking.
It really is. It's this often mind-bogglingly coordinated effort that makes everything else possible.
And what's truly fascinating here, I think, is how this isn't just about physically moving stuff, from point A to point B. The PMBOK guide, that's the project management body of knowledge, basically the standard for project management best practices globally. It really emphasizes what it calls a systems view of value delivery. So we're looking at something much more complex, a value chain. Projects don't just produce outputs like, walls or roofs, although obviously those are critical.
Right.
More importantly, those outputs, they enable outcomes. And those outcomes ultimately deliver strategic value to the organization, footing the bill and its stakeholders. The entire process, including this really intricate supply chain we're discussing, it's meticulously geared toward advancing these bigger organizational goals.
Can you give an example?
Sure. Think about a new hospital. It's not just a building, right? It's a facility designed to, say, improve patient health outcomes, offer cutting-edge medical services, maybe even boost the local economy with new jobs. The supply chain makes sure every single element, from the surgical lights down to the specific type of sterile floor tiles, contributes to that wider strategic aim.
That's a really crucial distinction. It's not just the building itself, the physical thing, but the whole underlying ecosystem of value that the building helps create. And that value chain, like you said, it starts way before the first shovel hits the ground. If we trace the journey of materials in modern construction, it's well, it's extensive. The CMA standards of practice, those are guidelines from the Construction Management Association of America. They define the life cycle of materials really broadly. It starts with raw materials acquisition and manufacture, then goes through fabrication, manufacture, construction, and use. And then importantly, it concludes with any of a variety of recovery, recycling, or waste management options.
Exactly. It's truly cradle to grave, or maybe quarry to concrete is more accurate for some materials.
Oh, yeah, quarry to concrete. I like that.
From the moment that stone is cut from a mountain or trees are harvested in a forest, through every single stage of processing, transport, installation. And then ultimately until the building is eventually decommissioned, maybe decades or even centuries later, and its materials are ideally recycled or properly disposed of the supply chain as this active, living network. This cyclical view really emphasizes sustainability and resource management as integral parts of the whole process, not just an afterthought.
And, while today we talk about complex recycling loops and global sourcing networks, the basic idea of managing materials from their source right to the site, that's as old as civilization itself. How did these challenges play out, say, in ancient times?
Well, that raises a really interesting point. Even way back then, the fundamental challenges of logistics, they were recognized. And often they came up with some incredibly ingenious solutions. A source like History of Architecture notes how early European commerce relied heavily on water transport. It says the transport of goods by water, much preferable to land routes, rivers, and littorals, had the advantage. You see this along the central trade axis, from the Low Countries through the Rhineland, down the Rhone into northern Italy, and then extending out into the eastern Mediterranean using galleys.
Wow.
This just highlights this long-standing understanding that water routes, they dramatically cut transport costs and boost efficiency, especially for bulky stuff like stone or timber or grain. It's a principle that, frankly, still holds true today for bulk materials. It shows that optimizing routes, minimizing transport costs, it's deeply ingrained in how we build things.
Absolutely. And think about the sheer scale of the challenges those ancient builders faced. I mean, imagine moving those massive stone blocks for, say, ancient Greek temples without any modern cranes or hydraulic lifts. Lectures on Architecture, Volume I, describes how they used very ingenious contrivances. Just fascinating stuff. Like, to lift those heavy cylindrical column drums, which could weigh many tons, they'd carve these special square holes, sort of dovetail-shaped, into the top. Then they'd suspend them using a specialized lifting device called a Lewis.
Clever.
Really clever. And for lintels, those long, relatively thin stone beams, they'd sink deep channels into the end joints to secure strong ropes and then hoist them up simultaneously from both ends. It really puts our current logistical headaches into perspective, doesn't it? When you think about the sheer muscle, the cleverness, and just the understanding of basic physics required back then.
It wasn't just brute force.
Not at all. It was applied engineering at its finest.
Indeed. And the cathedral builders gives us even more insight into those earlier logistical feats, especially on a grand scale like the European cathedrals. It details how crucial materials, like specific types of stone, were sourced, often from particular quarries chosen for their quality, maybe their color, or even just their proximity to the site.
Makes sense.
It highlights the vital role of the stonecutters, too. Their skill was paramount. And the importance of choosing the right materials, the right mortar. The text mentions things like experience of stonecutters, a better choice of materials, and better mortar, all contributed to the building of this type of vaulting, which became common around the middle of the 12th century. This just shows that even then, success hinged on this highly coordinated effort. You needed specialized skilled labor, careful material selection based on performance, optimized techniques. It was basically a sophisticated, albeit maybe more locally focused, supply chain.
Right.
It reminds us that quality control and skilled craftsmanship have always been tied directly to sourcing and delivering the right materials.
Okay, so moving from that broad historical sweep to the modern day specifics, let's talk procurement. And this isn't just, picking up the phone and ordering stuff from a catalog. Not at all. The CMA Standards of Practice lays out this really rigorous multi-step process. It says procurement includes advertising, the request for proposals or bids, pre-proposal, pre-bid meetings, addenda, receipt of proposals bids, bid review, and contract award. That's quite a list.
It is.
But even before you get to that stage, The project managers, they're often advising the project owners on really foundational strategic things like funding, permitting, contract packaging, phasing, interdependencies, design standards, and the management organization, as well as contract strategy and contract methodology.
Hmm.
So yeah, it's clearly not just going shopping. It's more like a strategic chess game. It involves complex financial arrangements, navigating this maze of regulations, and even deciding how the project itself will be structured, how it will be broken down into manageable parts.
Exactly. It demands huge foresight, a deep understanding of the market, and a really nuanced grasp of the project's specific challenges and opportunities too. And in that strategic chess game, the contract documents, they are the absolute rule book, non-negotiable. If we connect this back to the bigger picture, the main goal throughout this whole complex procurement dance, especially when you're negotiating with suppliers and contractors, is to hammer out what our sources call an absolutely watertight form of contract.
Watertight sounds serious.
It is, and it's crucial not just for legal clarity, though that's important, but really to proactively avoid disputes over who's responsible for what, and critically to prevent those costly and time-consuming cost overruns. We can see some powerful historical parallels here. Think about large-scale engineering projects like the building of the Great Eastern Ship. The biography of Isambard Kingdom Brunel details this. In that case, the lack of a really clear, thoroughly defined contract with the shipbuilder, a guy named John Scott Russell, it notoriously led to, and I quote, a heated discussion abounding in personalities,
Yeah.
and a formal inquiry into how a staggering £346,000, a huge sum back then, had been spent on a ship that was still nowhere near ready for sea. Lessons like that, historical ones, they really powerfully underscore why you need precise, unambiguous contracts. It hasn't changed.
Wow, that's a powerful and, yeah, unfortunately timeless example, isn't it? How crucial clarity and foresight really are. Even with the best intentions, a fuzzy contract can just unravel everything, turning what should be a partnership into this adversarial battle. But, even with the most watertight contracts, the reality of construction is, well, things change. Scope creeps, discoveries are made on site. So, speaking of contractual clarity, one thing you see in almost every project is the change order. The CMAA standards define it as a written agreement or directive between contracted parties which represents an addition, deletion, or revision to the contract documents, identifies the change in price and time, and describes the nature or scope of the work involved.
Right. It's basically a formal amendment.
Exactly, a formal, mutually agreed upon tweak to the original deal. However, there's also its more contentious relative, the Construction Change Directive, or CCD. Project Management in Construction explains this is something an owner can issue when there is no agreement on cost. Okay, so a standard change order is like a mutual handshake, a formal collaborative agreement. But a CCD, as you just laid out, that sounds more like the owner saying, look, we need this work done, we're doing it now, and we'll figure out the exact price later. Is that right?
That's essentially it, yes.
That must take a significant amount of trust between the owner and the contractor. Or, I guess, a really strong underlying contract that allows for it and spells out how costs get sorted out afterwards.
Precisely. It essentially shifts some of the initial financial risk from the owner onto the contractor, at least temporarily.
Liz.
Exactly. And the implications of a CCD, they can be pretty substantial for both sides. For the owner, yeah, it keeps the project moving, avoids getting totally stalled by price arguments. But they carry the risk of potentially higher costs down the line if negotiations don't resolve favorably. For the contractor, well, they have to proceed with the work without a finalized price, essentially trusting the contract's dispute resolution process, to be fair. And this is precisely why the level of detail in cost management and those cost breakdowns becomes absolutely critical.
Right, you need proof.
You do. It's not just good accounting practice. It's fundamental for understanding the true cost drivers, for negotiating effectively, and for backing up your claims, especially when you're dealing with change orders or complex subcontracts. Without clear, really granular cost breakdowns spelling out labor, hours times rate, materials with specific quantities or dimensions, plus allocated overhead and profit, how can either side even begin to control project expenses? Or verify if a bid is fair, or assess the real impact of a change.
Makes sense.
Construction management actually shows a typical invoice structure with elements like product ID, quantity, unit price, line total, and then taxes like PST, GST, plus shipping and handling, leading to the total due.
And just to clarify for listeners, PST and GST are typically sales taxes, like prudential sales tax and goods and services tax, often seen in places like Canada. Adds another layer of detail to track.
It does. And furthermore, this detailed cost tracking, it has really vital longer-term benefit too. The same source points out that a project parameter cost model form should contain actual costs of the completed project that can be compared to estimated costs. So these meticulously recorded unit costs, they become invaluable historical data. They significantly enhance your conceptual estimating knowledge for future projects.
Ah, so you learn from project to project.
Exactly. What you painstakingly record and analyze today directly helps you create smarter, more accurate bids and more realistic budgets tomorrow. It creates this powerful feedback loop for continuous improvement in the industry. It's basically about turning raw data into predictive power.
Okay, let's shift gears a bit now and talk about a concept that's really revolutionized a lot of industries, including construction, over the last few decades: just-in-time delivery, JIT. It's a lean manufacturing idea, fundamentally, that aims to dramatically reduce the need for storing materials on site. The goal is to have materials arrive exactly when and where they're needed for installation, ideally not a moment before.
Right, minimizing inventory.
Exactly. And this approach, it's driven by core ideas of efficiency. Inspired by mass production models, explicitly aiming for low cost, and promoting a domestic economy, as noted in Blyer. Towards a new architecture, interestingly enough, you can sort of picture it like a perfectly choreographed dance, right? A highly synchronized ballet where materials arrive precisely on cue. This minimizes clutter on what are often already pretty tight construction sites. It also reduces the risk of materials getting stolen or damaged, and it significantly cuts down on waste. On paper, I mean, it sounds incredibly efficient, almost like a silver bullet for logistics challenges.
It does sound great, and the theoretical benefits, they could be substantial. You can save a lot on warehousing costs, inventory management, or the inherent risks, especially in a construction context, are equally significant. Our sources really hammer this home. JIT, just by its nature, it increases the risk of schedule delays if anything goes wrong anywhere in that complex, often global chain.
What do you come at all?
Anything. Thinking in systems explains this well. It notes that the time lags that come from slowly changing stocks can cause problems in systems. See, unlike maybe a car factory, which churns out thousands of identical units and can build up a buffer of parts fairly easily, a construction project is often a one-off prototype. It's built on a unique site with unique conditions.
Right. Every project is different.
Exactly. So if you don't have a buffer of material stored either on-site or somewhere easily accessible nearby, a single delay in one part of that supply chain, maybe a crucial component gets stuck in customs, a delivery truck breaks down, there's a port strike, an unexpected manufacturing glitch, even just bad weather, that one delay can ripple through the entire project schedule. It can halt work for a whole crew, lead to costly idle labor, and cause costs and penalties to just escalate.
That sounds like a nightmare.
It can be. This is where that weakest link metaphor really hits hard, with potentially profound consequences. It makes robust risk mitigation strategies, like the ones outlined in the PMBOK guide, absolutely essential if you're even thinking about implementing JIT in construction. You have to plan for failure.
Yeah, that's such a classic frustrating scenario, isn't it? The best laid plans just seem to unravel because of these unforeseen hiccups.
Yeah.
There's a real-world example from the book house that perfectly captures this tension and the human side of it. A contractor is recounting this frustrating experience where they were told, quote, "The first time I heard it wouldn't be September 1st was a week ago."
Ouch. Last minute.
Exactly.
Right.
That kind of last-minute communication, or often the complete lack of it, can be absolutely devastating for a tight JIT schedule. I mean, imagine a crew of dozens of highly paid tradespeople showing up, all ready to install structural steel, only to find out the steel isn't there. Why? Because of a week-old delay notification that somehow never got passed down the chain.
It happens.
It leads to those heated discussions, massive rescheduling headaches, and unexpected costs that just eat away at already thin profit margins.
And to try to mitigate this inherent variability and risk, lean principles have become increasingly important in construction. Moving beyond just JIT to a more holistic approach to production control. One key methodology here is the last planner system, or LPS. It aims to optimize how work actually gets executed through a highly collaborative and structured planning process. It puts a big emphasis on making commitments and then actually honoring them. You have individuals, the last planners, often foremen or crew leads, making explicit promises to attend planning meetings, come prepared, and crucially deliver on their assigned tasks within the agreed time frame.
So it's about accountability.
Huge accountability. It shifts the focus from just reporting on what has happened, which is reactive, to actively making and keeping promises about what will happen. That's proactive. And there's a fascinating cultural change highlighted in the practitioner's guide for the last planner system. It states, In order for someone to say yes to a request, they must have the ability to say no. If they cannot say no to a request, then they cannot make a promise.
That's interesting. The power to say no.
It's a profound shift in dynamic, really.
Hmm.
It moves away from a culture where maybe subordinates just passively accept whatever tasks are handed down, regardless of feasibility. Instead, it moves towards a culture where individuals are empowered to make realistic commitments based on their actual capacity, the available resources, and potential constraints. This accountability is just foundational for reliable planning and for identifying potential roadblocks early on. Plus, more sophisticated production control systems now integrate physical control, software, like control solutions including sensors, and human control to actively manage that variability. They strategically allocate buffers, maybe buffers of time or materials, or even capacity where they're most needed. This helps ensure that unforeseen issues don't completely derail the project's delicate balance.
So it's not just about having a strict schedule printed out. It's more about building this robust culture of accountability, empowering individuals to make realistic, informed commitments within the system, and actively anticipating where things might go wrong, building in that cushion.
Precisely. Building in resilience. And if we connect this to the bigger picture again, the level of detail needed in planning, the frequency of control checks and feedback within any production control system, it really must be meticulously aligned with a specific type of project and its inherent variability.
Okay, so it's context dependent.
Very much so. For example, a greenfield residential project. Building new houses on undeveloped land where the scope is relatively stable and the work is quite repetitive typically experiences less variability than, say, a major refinery turnaround project. In refinery shutdown, the scope is almost expected to constantly change based on what engineers discover when they actually open up the equipment. And the financial penalties for delays, they're exponentially higher.
Millions of dollars, potentially.
Easily. A week's delay in a refinery turnaround could have direct multi-million-dollar impacts on the company's revenue, even its valuation, whereas the same delay might have less severe, though still significant, implications for a single residential homeowner. This just underscores the need for highly adaptive, context-specific, and agile supply chain management strategies. One size absolutely does not fit all in construction logistics.
Now, those theoretical risks of JIT delivery and just the inherent fragility of long, complex supply chains, well, they've been brought into extremely sharp focus by real-world events in just the past few years, haven't they?
Absolutely.
Hard lessons learned.
So,
We've witnessed these profound disruptions, as our sources call them. Disruptions caused by everything from global pandemics shutting down factories and snarling up shipping lanes, to escalating trade disputes, imposing tariffs, and blocking the movement of goods. These aren't just abstract risks you list on a spreadsheet anymore. They're real-world headaches that can set a project back months, maybe even years.
yeah.
They cause immense financial strain and can really damage reputations. And, we can even look back historically to see how profoundly disruptions, even natural ones, can impact grand visions and rigorous schedules. Take Isambard Kingdom Brunel, the famous British engineer. He faced constant problems with slipping of heavy clays when building his railway embankments. It caused him, according to his biography, infinite trouble and anxiety, especially during a particularly bad winter in 1839.
Oh.
It even led to the derailment of a mail train. These kinds of geological challenges, unpredictable, powerful, totally beyond human control, they're not unlike modern-day material shortages or shipping blockages, are they?
No, the principle is the same. Unforeseen obstacles.
They're stark reminders that even the most meticulously planned projects are always, well, to some extent, at the mercy of the unforeseen. Even the greatest engineers can't outsmart geology, or a global pandemic, for that matter.
And given these profound disruptions, both the historical ones and the very contemporary ones we're living through, robust risk management isn't just, a best practice. It's an absolute necessity for survival and success in this industry. The CMAA Standards of Practice defines risk management quite clearly. It's the process to methodically address risk and work to lessen the impact of the occurrence of risk events on a project or program in all phases of development. Notice the word methodically. This isn't a reactive, panic-driven strategy. It's a deeply proactive, forward-looking approach that needs to start right at the project's inception.
From day one.
From day one. It involves early identification of risks and opportunities, because sometimes risks have upsides too. Then diligently tracking them throughout the project lifecycle and strategically deciding on the best response for each one. Practical strategies include things like transferring the risk to a third party, maybe through performance bonds or specific types of subcontracts, or mitigating it using mechanisms like comprehensive insurance policies, or even strategically stockpiling critical materials if feasible. Or, ideally, you try to minimize or eliminate the risk altogether through clever design choices, thorough engineering analysis, or maybe finding alternative material sources or suppliers. The PMBOK guide elaborates on these concepts too, talking about risk sharing and risk mitigation, underscoring the multiple tools project teams have to build resilience. And if we take a systems view, like the one proposed in Thinking in Systems, it gets really insightful. The book says the structure of a system is its interlocking stocks, flows, and feedback loops. Understanding this underlying structure, it argues, is the key to understanding not just what is happening, but why.
Okay, so applying that to the supply chain.
Right. When a supply chain gets disrupted, whether it's by a hurricane, a geopolitical event, or just a simple manufacturing defect somewhere, it's the system's inherent structure that determines its vulnerability or its resilience. How do materials flow? How are decisions made about inventory levels, the stocks? How does feedback about delays or shortages influence future ordering and delivery schedules? The feedback loops. By mapping out these dynamic elements, project managers can get much better at anticipating potential shocks, identifying the critical bottlenecks, those weakest links again, and designing the system for robustness, not just for maximum efficiency alone. Sometimes a little inefficiency is the price of resilience.
So it's really about being profoundly proactive, isn't it? Not just reactively putting out fires when they inevitably flare up, which seems to be a massive theme running through modern project management thinking.
It absolutely is.
It involves meticulously understanding the entire project context, including those specific risks and parameters that the project team worked with, such as budget and schedule, as the practitioner's guide notes. It's about building in flexibility, maybe some redundancy, and definitely foresight right from the very beginning, always asking what if at every turn, and crucially, having credible contingency plans ready for those what if scenarios when they actually happen. Okay, let's shift our focus now to how technology is fundamentally changing this whole complex landscape. How it's bringing really unprecedented visibility and control to the construction supply chain. We're seeing the rapid rise of these sophisticated track and trace systems and logistics software. These allow for pretty much real-time monitoring of materials as they move from some distant factory all the way to the job site gate.
Huge improvement.
Huge. But maybe the most impactful, the most truly transformative development that's rapidly gaining ground is the BIM environment. And BIM building information modeling isn't just about creating fancy 3D models of a building anymore, is it?
Not at all. It's evolved way beyond that.
The BIM handbook describes it as a comprehensive, intelligent data management system, one that integrates various different software applications and rigorously supports an organization's information policies and practices.
Yeah, what's truly fascinating here is how BIM is moving far, far beyond just basic design visualization. It's rapidly becoming, you can almost say, the central nervous system for virtually all project information. And that crucially includes supply chain data. The BIM handbook clarifies that these BIM environments, they can carry much wider forms of information than model data alone. Things like video clips, images, audio records, emails, all sorts of other information used in managing a project can be linked directly to the model components.
So everything's in one place.
Exactly. It creates this single, integrated source of truth for everything related to the build. This makes collaboration and just sharing information incredibly efficient. It means everyone from the architect in their office, to the fabricator in the workshop, to the site manager out in the field is working from the same, most up-to-date information. That drastically reduces errors and miscommunications, which are huge sources of delay and cost.
Okay, and here's where it gets really interesting for me. The implications for logistics and procurement seem revolutionary. Take quantity takeoff, or QTO. Traditionally, that was this painstaking manual process, right? Measuring lines on drawings, counting things up. Very prone to error.
Extremely tedious and error-prone, yes.
Yes. But the BIM handbook explains how BIM data can be automatically extracted for incredibly accurate cost estimating, later for purchasing and materials tracking, or maybe to associate with work packages and scheduling. I mean, just imagine having precise digital models that automatically tell you exactly how much of every single material you need, down to the last brick, the last liter of paint, the last length of pipe, and then it even helps you track its delivery status as it moves through the supply chain.
It changes everything.
It seems like it would dramatically reduce waste, virtually eliminate those manual errors in ordering, and drastically improve the accuracy of budgeting right from the start.
And that raises an important question, doesn't it? How does this real-time updating capability fundamentally change how we actually manage material orders and inventory day to day.
Huh.
Think about parametric modeling that's a core feature of BIM. If a single wall is moved in the digital model, all those that abut it should update as well, because the software understands their relationships. Changes propagate according to their connectivity.
Wow, automatic updates.
Automatic updates. So as design changes occur, even minor ones, the quantities of materials required are immediately and automatically updated throughout the entire BIM model. This vastly reduces the chance of ordering too much or too little. It cuts down waste, prevents costly reorders for things you forgot, and eliminates that whole time-consuming process of manually recalculating everything whenever there's a design tweak. You transition from this reactive, often error-prone, manual adjustment process to a proactive, integrated, almost self-correcting system.
And it gets even more dynamic, right? Bringing the actual project schedule into the visual model. The CMA, Standards of Practice, talks about 4D schedules. These dynamically link the project's CPM schedule activities, that's the critical path method, identifying the key sequence of tasks directly to the 3D objects in the BIM model.
Connecting time to the 3D space.
Exactly. So what you get is, quote, a graphically rich and animated representation of the planned construction sequence set against time. It's not just a flat Gantt chart anymore. It's like a virtual walkthrough of the construction process. It visually shows how everything is planned to unfold day by day or week by week.
Incredibly powerful communication tool.
Hugely powerful for phasing, coordinating, and communicating planned work to everyone involved. From the high-level stakeholders right down to the crews on site. It allows you to proactively spot potential clashes or logistical bottlenecks before they ever happen out in the field.
And building directly on that 4D concept, BIM also offers 5D cost management capabilities, the fifth dimension being cost. So every single element in the BIM model, every wall, window, pipe, light fixture, can have specific resources and costs attributed to it. This allows for parametric and dynamic quantity takeoff for bills of materials, meaning as the design evolves and changes, the cost estimate evolves with it in real time. It provides immediate financial feedback on different design choices. Is this more expensive option worth it? The model can tell you instantly. This dynamic capability leads to a more accurate estimate, and therefore the estimators spend less time just counting things, quantity takeoff, and more time actually analyzing costs, exploring value engineering options, and managing the budget actively. It fully integrates cost right into the design and scheduling process, makes financial management much more transparent, much more responsive, and ultimately more accurate. It really is a game changer for budget control.
And looking beyond just BIM, this broader ecosystem of smart systems and sensors seems to hold immense potential for the future of construction logistics, too. The city of tomorrow, while mainly talking about sensor networks saving energy in buildings after they're built, the underlying principle seems directly applicable to the construction site itself, doesn't it?
Absolutely. The potential is enormous.
Imagine smart materials with embedded RFID tags that announce their arrival. Sensor-equipped machinery reporting its exact location, its fuel level, its maintenance status. Or even drones continuously monitoring site logistics, tracking progress, maybe even spotting safety issues, all feeding real-time data into a central intelligence system.
A fully connected, responsive construction environment. That's the goal. And we can already see this trend taking off in related fields, which gives us a hint of where construction might be heading. Designing Reality points out that today's fab labs, these digital fabrication workshops, they already rest on a global supply chain to source things like integrated circuits, precision tooling. This clearly shows the broader ecosystem of advanced manufacturing and digital fabrication that construction can increasingly tap into and integrate into its own supply chains, bringing those advanced techniques onto the building site. Furthermore, the incredible success of robust marketplace platforms like Amazon or various app stores where, as the book notes, great wealth and influence accrue to those who control the leading marketplace platforms, well, that suggests the construction industry is actively looking for similar digital platforms.
Like an Amazon for construction materials.
Essentially, yes. Platforms to streamline procurement, manage logistics more efficiently, and connect all the stakeholders more effectively across this increasingly complex global supply chain. The ultimate goal is to create an integrated, transparent, and highly efficient digital marketplace for everything needed to design and build.
Okay, so after this journey, traversing the globe, tracking materials, dissecting the strategic dance of procurement, navigating the tightrope walk of just-in-time delivery, and getting a glimpse into this digital-first future, what's the ultimate bottom line here? It seems crystal clear that supply chain management is not just a back-office function. Not anymore. It is a critical, maybe even the critical component of overall project success.
Couldn't agree more.
It's easy, I think, to dismiss logistics as just, moving boxes from point A to point B. But as we've seen today, it's fundamentally about proactively managing risk, efficiently allocating precious resources, and ultimately delivering on the promises made to clients and stakeholders. The CMA Standards of Practice define construction management itself as the practice of professional management applied to the planning, design, and construction of projects from inception to completion. And for what purpose? For the purpose of controlling time, scope, cost, and quality. When you really think about that definition, it becomes starkly obvious that logistics and supply chain management directly impact all four of those critical pillars.
Every single one.
A breakdown or even just a significant inefficiency in the supply chain. It can blow the schedule completely, it can expand the project scope through necessary rework or forcing alternative, maybe less ideal solutions. It can inflate costs dramatically through delays, expedited shipping fees, idle crews, and it can even compromise the final quality if rushed substitutions have to be made.
It really is the engine.
It's the engine that powers the entire project's ability to meet its fundamental objectives. Time, scope, cost, quality, liberation. The supply chain hits them all.
And if we connect this back to that bigger picture one last time, the PMBOK guide offers a profound reminder. It says projects do not simply produce outputs, like the physical building, but more importantly, enable those outputs to drive outcomes that ultimately deliver value to the organization and its stakeholders. An efficient, transparent, and crucially resilient supply chain is precisely what ensures that this entire value chain remains unbroken. Right from the initial strategic intent, the business case for the project, all the way through to the final handover and occupancy of a fully functional, high-quality building. The supply chain is the fundamental engine powering the realization of those strategic goals. Without a functioning supply chain, even the most brilliant designs and the most ambitious visions, they remain just that, visions on paper.
And this all boils down to that powerful, timeless lesson we've touched on throughout this deep dive. It's something that resonates far beyond just construction, I think. And that is, a project is truly only as strong as its weakest link.
The classic aphorism. Still true.
It's such a powerful reminder, isn't it? You can have the most visionary architects on board, the most innovative, sustainable designs, the most skilled and dedicated construction crews, the most advanced digital technology running everything. But if the right structural beam doesn't show up on Tuesday morning, or if that specialized custom window panel is delayed by a month because of a port strike halfway across the world, the entire multi-million-dollar endeavor just grinds to a halt. The whole chain is only as strong as that single, often unseen, fragile connection.
And this relates directly back to system dynamics, actually, where, as Thinking in Systems notes, time lags that come from slowly changing stocks can cause problems in systems, but they also can be sources of stability.
How so? Stability.
Well, an overly slow or inflexible supply chain can definitely cause delays and problems. A well-managed one, even with inherent unavoidable time lags, can strategically provide a necessary buffer, a cushion, a crucial degree of stability. That buffer gives you room to maneuver, allows you to adapt to unforeseen circumstances, and helps mitigate the ripple effects of minor disruptions before they become major catastrophes. The critical balance, the real art, lies in understanding and strategically managing these complex flows, identifying those potential bottlenecks early, and intentionally building in resilience without sacrificing too much efficiency. It's a constant dynamic optimization problem.
Well, we've certainly covered a lot of ground today. We've traversed the global pathways of materials, delved deep into the strategic dance of procurement, navigated the precarious tightrope of just-in-time delivery and all its inherent risks, and peered into the exciting, data-driven future of digital-first logistics and smart construction systems. The construction supply chain, far from being some mundane back-office detail, is clearly a dynamic, living, and incredibly intricate system. A system that underpins every grand structure we admire, every building we live and work in, and every city we call home. So, what does this all mean for you listening today? Well, maybe the next time you walk past a bustling construction site, consider not just the rising steel and glass, the visible progress being made. Take a moment to reflect on the vast, invisible network that enables it all. Think about the thousands upon thousands of decisions, negotiations, physical movements, and sheer coordination that had to happen perfectly, often spanning continents and involving countless companies and people just to make that visible progress possible. And perhaps ask yourself this: if every grand vision, every complex human endeavor, like building a skyscraper, relies on such intricate, often fragile, hidden connections, what does that teach us about the complex systems operating in our own lives? And what about the unseen dependencies that allow our own worlds, our jobs, our communities, our daily routines to function day in and day out, often without us ever giving them a second thought?